Hello everyone. Today we have a very quick showcase on a small little part of a very big project for the Amelix server, and this is wireless serial transmission, or we call these RUD cards. RUD stands for Redstone Update Detector, and using this we can send binary data across any dimension, as long as it's the same dimension, and we can send it between farms or any redstone contraption that we want and send instructions to control farms remotely. And this is showcased of the technology, and these RUD cards that we call can both send and receive information. And over here is a temporary, this is just a transmitter, and this is what we're using to set the data on the RUD cards. In the actual final version, there will be a serial input for actually loading the data in, but this is just a temporary setup to showcase it. So first we will turn the power on, and we want to receive data, so we turn off transit mode, and we set the power on for this transmitter. And how we will sync all of these up, since they are wireless and are far apart, is we will use daylight sensors on the server. The actual setup will be a lot more complicated than this, since we have multiple points of the day that we'll use to sync these up together as accurately as possible down to the redstone tick. But for this showcase, we'll just use command blocks to quickly turn it from night to day and detect that. So you can see this is primed and ready to receive information, and this is the binary code we want to send. And if we press this, turn nighttime to day, you'll see both activate, and then the code is transmitted one for one across. Now there is an inversion, and that's just the nature of this. That's easy to solve with just a torch. But now let's turn this one off, since this was just a temporary system to get the data into this card. And now we want to enter transmission mode. So now this will broadcast the data into the network. And then let's turn on this card, and this will receive the data. And if we send the global signal again, you'll see the data gets transferred right across. Now there always is an inversion. That's just because there was a torch here. Adding another torch simply removes that inversion. So that's not really a problem. And you can see that all these turned off. What this signifies is that each one of these bits got transmitted correctly. The problem with these redstone update detectors is, you can see one right here, is that any update to the world, such as blocks being placed on redstone, sends a rogue signal. So if you have other redstone contraptions, they can send random signals or noise into the system, and that's very bad because that's interfering with the data. So how do we make sure that the data is correct and has been correctly transmitted? Is that since these are a pair of receivers and transmitters, when the transmitter sends the data, the receiver on the card itself also listens and makes sure that each bit has been transmitted correctly. If not, it sends another signal telling the receiver that there was an error. And we can do this because we know that if there is no signal, that is always correct. That's because it's impossible to get noise in a way that a sent bit doesn't arrive. A sent bit always does arrive. The problem is that sometimes when you don't send a bit, there could be a false positive. So we use that mechanic to slowly whittle down the ones that we actually have sent. So Totem just sent this back over here. But on this next time, I will be placing redstone components to cause artificial noise, and you'll see some of these bits fail to send. But when that gets detected, it will fix itself. So we enter transmit mode, and this one is now receiving. So we turn the power on and reset it, and now it is ready. So I will do this. Instead, this time I'll place torches, and you'll see some of these bits not get transmitted. You'll see with that there was an error. But no matter how many times I tried to mess it up, eventually all bits will get transmitted reliably. And this is a 100% guarantee. This is not chance. This is nothing to do with traditional error checking, such as ambient codes, where there is a threshold of the amount of errors. This will transmit with 100% reliability, since the transmitter itself has what the receiver has received exactly, and it can do a comparison between the two. And that is basically how we negate the noise, as this is a large problem with using these wireless redstone contraptions, as any update to the world related to redstone, including pistons pushing blocks, causes these problems. And these are some older versions. This uses a less sophisticated method of detecting errors, where the entire set needs to be correct at once. And this is only a receiving end, and this is only a transmission end. So this is a lot more complicated. And this one doesn't have any error corrections. It's just a simple receiver and transmitter. So this is what we started with, and this is our final design, at least for the core of the system. There will be a lot more logic. As you can see, these first 8 bits are the addresses. So each one of these cards will have a value assigned to them, and you can send this actual data, which is 27 bits. It can be any length, but we have 27 since we store the data inside of shulker boxes. But we can send the data to any value using this address set. And that is basically how this system works. It's been a long time in the working, but we finally got a very nice and compact system, which, if you may have noticed, is completely observerless, to avoid any pending tick issues. And the timings are extremely precise, and we don't want anything to mess up. This is observerless. This observer is just for just basic wiring. It isn't actually part of the logic. And yeah, that's really it. And thank you for Totem for a lot of the math that went into this and the genius behind most of this work. And this is related to the haste network, as these two systems will communicate, so stay in tune for that later. Thank you. See you guys in the next one.